Well, hello everyone. Thanks for having me here. Yes, I'm Toby Gill, CEO of IPG Energy, a British climate tech company working to accelerate the transition away from diesel generators in hard-to-abate sectors, starting with the construction side. So I have kind of three key goals of my talk and time with you today. Number one is to say that basically and convince you that despite obvious, ambitious net zero commitment, diesel generators are incredibly hard to replace in the hard-to-abate sectors. Obviously, starting with construction. Number two, that the chicken and egg sort of market dynamics in, say, the green hydrogen economy are really putting net zero for this on-site power provision in these hard-to-abate sectors at risk. And then finally, that fuel-agnostic generators are a sort of relatively unique way of offering a route to solving that problem. So, let's get into this. Hello? There we go. So, first things first, I hope that from a climate perspective, we can all agree that diesel's not the greatest of things. And so it really then does beg the question as to why, despite all the progress we are obviously making with wind, solar, energy storage, and the drive to renewable fuels such as green hydrogen, why is it then that the global diesel generator market is still projected to almost double out to 2030? Now, the short answer for this is in markets like construction through to mining, from data centers even to backup power for wind farms, diesel generators are an incredibly cost-effective way of ensuring that you have the power you need exactly when and where you need it. But obviously, as we've kind of just heard a lot of recently and through the whole conference, our goal is to get to net zero, obviously by 2050, and indeed in other sectors by 2030. And we're in real trouble of not achieving this if we don't address these challenges. Now, obviously, we face a problem with that, though, and that problem is that hydrogen generators, be that a fuel cell, an internal combustion engine, or any other technology, is actually the rate of those getting into the market is absolutely constrained, obviously, by the availability of, say, green hydrogen to power them. But the growth of that market for these industries is constrained by how many generators there are to use that fuel, and I think you can obviously see there's a bit of a chicken and egg impasse there, and how do we rapidly grow that? So with optimistic market projections putting that by number, hydrogen generators might make up to 10% of the market by 2030, and then optimistic energy outlook saying that maybe 21% of our energy mix globally might be 21% by 2050, you start to get a picture where you feel like it's going to be very difficult to believe that we're going to do anything other than rely on diesel and natural gas for the majority of our power provision in these markets. And therefore, obviously, we really might not achieve our goals. Now, obviously, what I'm not saying here, or I hope what I'm not trying to convince you of, is I'm not condemning fuel cells and other hydrogen technologies. They're fantastic solutions that we need to scale to help us achieve our goals, but they're going to provide a really competitive and valuable solution for this 20% of the market. The question I have is there something else that we can do that enables the other 80% to accelerate how they contribute to net zero? So, obviously, with any emerging technology, one of the key barriers to getting to sort of mass adoption is essentially price parity with the incumbent solution, right? Now, within this is a very easy thing to say, difficult thing to deliver. And that's because, to simplify what is clearly a very complicated problem, the route to achieving cost parity in these markets is through the increased production of renewable fuels to benefit from economies of scale and therefore make it a simple economic imperative to switch from diesel to, say, green hydrogen. But as we said, how can we do this when the route to greater production is through greater demand, which we can only get through from greater production? And I hope with my sort of somewhat subtle chicken and egg logo, you can kind of figure out the point I'm trying to get at, right? Now, eventually, given a sort of stepwise and incremental increase in supply and demand for green hydrogen, we'll get there and we'll sort of unlock that price parity and be able to get greater growth. But the question is, obviously, will we get there soon enough? To unlock this growth sooner, what we need is something that can substantially grow demand ahead of supply, creating clear incentive for greater production, thus minimizing the risk of greater investment into green hydrogen production and the production of other renewable fuels. And this is exactly what fuel-agnostic generators can do. As we've seen before, this is our sort of indicative curve for maybe hydrogen penetration into the market. And in contrast, fuel-agnostic generators, as a single asset uniquely capable of operating on any fuel at the flick of a switch, can achieve market penetration without reliance on the growth of any individual renewable fuel market. And as their growth is unconstrained by, say, the green hydrogen economy, this means that they can provide a cost-competitive solution for the 20% of the market that is using renewable fuels, and also the 80% of the market that's reliant on conventional fuels. So what I have just said is that I want us to replace diesel generators with fuel-agnostic generators that run on diesel and natural gas. That is what I just said. The reason I'm saying that is because by flooding the market with fuel-agnostic generators, they can provide the essential power that is needed on conventional fuels, while simultaneously creating increased demand for green hydrogen and other renewable fuels ahead of that abundant supply. By breaking that chicken and egg impasse in this way, fuel-agnostic generators, through that increased demand, will ultimately increase the total number of generators that are operating on renewable fuels in the market, thus enabling these hard-to-abate sectors to achieve greater decarbonization sooner. So to convince you that this is something that practically works for a business, what I want to do is dive into how this works for a construction company and why they would want to do this. So we know from conversations with our customers that this is obviously an industry with a huge ambition to achieve net zero and a willingness to pay a green premium to a point to adopt the solutions to help them get there. And indeed, industry leaders are exploring lots of ways to ditch their diesel generators already. Take Mace Group, for example, who have already banned diesel generators across the whole company, predominantly reliant on HVO to do that, whilst they look for other greener solutions. And Balfour Beatty, who have kind of made a very clear intent to push their supply chain to offer them cost-effective zero and net zero carbon solutions. So why then, given that ambition, is it still an industry that is essentially 100% dominant on diesel, reliant on diesel generators? Well, it comes down to the fact that whether it's a two-house development or a large national infrastructure project, for construction companies, diesel generators are the cost-effective solution. They're the benchmark of that, what that means for power provision on these sites. They're essentially, this is not a real word, but I couldn't really figure out a way of saying it, but they're essentially at no risk of being stranded. You know, there's lots of diesel, they're reliable, it's easy to maintain, no risk associated to them. And when you can combine that with an established supply chain and a diverse supply chain, and also the fact that they can benefit from sort of weeks' worth of on-site fuel storage with diesel, this provides them the benchmark of basically a trusted and reliable solution for getting the power that they need to do the job they need to do. And the harsh reality is that when it comes to most of the renewable generators on the market today, this just simply isn't true. Because, of course, it's important to remember that the number one driver for these businesses is obviously, of course, still just cost. And when it comes to decarbonizing their on-site power provision, there are three key costs that these customers are really concerned about. Number one is clearly the capital cost of investing in an expensive renewable solution that's practical use in their business is intrinsically linked to the use of a very expensive renewable fuel, which in turn leads to risk number two, which is the increased risk of that asset becoming stranded by fluctuating fuel costs and the general evolution of the renewable fuel market. You know, the question they do ask themselves is, what happens if hydrogen doesn't become the fuel of the future? Have we just made a really bad investment? And finally, number three is the less obvious but highly impactful risk of increased costly delays to build programs caused by disruptions from a renewable fuel supply chain. Now, these can run into the tens, if not hundreds of thousands of pounds per day for every day that a project overruns, and therefore that increased risk presents quite an untenable thing for them. So because of these risks, as I said, present an untenable hurdle for the majority of the industry to cross, businesses are basically stuck relying on diesel generators, and they're unlikely to achieve their net zero goals for decarbonizing their on-site power provision. So this is where fuel-agnostic generators, as I'm hopefully convincing you, provide the answer. Firstly, a fuel-agnostic generator offers cost competitivity. Now, this is to a diesel generator when, say, operating on diesel or natural gas, and to a hydrogen fuel cell when operating on hydrogen. Secondly, they eliminate the kind of stranded asset risk that you get with a fuel-specific renewable generator, because what they can do is essentially say, look, I can switch my diesel generator to a fuel-agnostic asset today, safe in the knowledge that I can rely on cost-effective fuels, whatever they may be, renewable or conventional, at any one time, and therefore I will be able to make use of this within my business to do the job that I do, which is build something. And thirdly, operational security is ensured by being able to call upon any fuel supply chain, eliminating those day-to-day risks of project delays from changing between different renewable fuel supply chains. At the end of the day, having the certainty that they know they could run their businesses and those sites on diesel or natural gas is an essential step to increasing their appetite to take steps away from it in the first place. So obviously, it won't come as any surprise that the reason I've been banging on about fuel-agnostic generators and the value of this is because IPG Energy has developed one of these, and we think we've got one of the best ones out there, the IPG flameless generator. Our product delivers those market dynamic changing benefits of fuel-agnostic generators at a competitive cost. And we do this with our patented flameless combustion technology that not only delivers the ultimate in clean fuel-flexible power, but does so without reliance on complex materials and manufacturing processes, which obviously plays a significant role in reducing the capital cost for our technology. It also has the benefit of being pollutant-free no matter the fuel that's being used, and this allows our customers in the construction industry to achieve their sort of targets for healthier job sites, meet tightening air quality regulations, and benefit their local communities, all things they're very keen on doing. And therefore, we believe this provides a really fantastic route to delivering clean, on-demand power at scale for these businesses to help them ditch their diesel generators. Now, for the technically minded of you out there who want to know how this works, I'm going to quickly go through it, won't bore you with all the details. But our innovation is centered around our flameless combustion as our core technology and is then supported by 3 auxiliary processes. There's a compressor, a heat regenerator, and a ceramic turbine. So firstly, compressed air enters our compressor, gets compressed, and gets passed into our heat regenerator. Waste heat from our ceramic turbine preheats the airstream to above 800 degrees Celsius before it enters our combustion chamber. Now, these high temperatures ensure that any fuel will auto-ignite without the need for a flame. So in the flameless combustor, all we need to do is take the chosen fuel, inject it into the airstream, where it auto-ignites and increases temperatures up to about 1250 Celsius. What we do is we rapidly disperse the fuel in that hot airstream to prevent there being any fuel-dense regions. This prevents the formation of a flame, which is important because that ensures we don't form those polluted emissions such as nitrous oxide, particulate matter, carbon monoxide. The hot pollutant-free airstream then flows into our ceramic turbine, where it spins it around, spins a motor, generates electricity for the end user. And then finally, waste heat goes back through the heat regenerator, charging it back up. And then what happens is we exchange those thermal cores to be able to provide a constant flow of hot and cold air for the system. So that's how it all works. What we have, therefore, is this is not how it actually looks, by the way. This is a really simplified out diagram of it. But what we have is a technology that can work not only, as we said, on today's fuels, but also the renewable fuels of tomorrow's, as including hydrogen, ammonia, biogas, biomethane, ethanol, methanol. I could keep going on. I think you get the point. But obviously, it also works on natural gas and diesel. It also works on blends of these fuels. In particular, it's very easy to blend gaseous fuels and liquid fuels together. And so this was obviously just a whistle-stop tour of how this works. If you're interested to learn more, there's a QR code you can look to, or come and find me later. So that's how it works and why we think it's valuable. Obviously, the next question is, what are we doing with it? Well, we're recently following a successful £1 million project with National Highways and 2 angel-backed seed rounds totaling £3 million. We're actually going to be launching our £10 million Series A round soon, with which we want to build upon an ongoing pilot trial with a leading UK construction company to target selling 50 units into a high-profile net zero infrastructure project in the UK, and basically we're going to be hoping to grow from there. This is then in partnership with the Advanced Manufacturing and Engineering Institute. We want to scale our production capacity from where we are now to, say, even as low as 100 units a year, where we can also not then provide just cost competitivity to the fuel cells, but also to diesel generators when operating on conventional fuels. And we think that will provide us a really strong foundation to then set the stage for further growth from that point onwards. So to bring it quickly to full circle, I hope what I've been able to convince you of is my 3 points in this talk, which is obviously number 1, that despite diesel generators being hard to replace, there is appetite to do so, and we can try and capitalize on it. The challenge is around scaling renewable fuels in these industries, like green hydrogen, and of course, we believe we have a way to help accelerate that transition with fuel-agnostic generators, and in particular, the IPG flameless generator. So if you're interested to hear about more about the virtues of fuel-agnostic power and how it could help either one of your businesses, or indeed if you're interested to learn more about our investment raise, I'd be happy to hear from you after this. Thanks very much.